I'm now starting the homework questions on lesson number 3 in the circle geometry chapter. And for question number 1, I need to find angles 1 and 2. You can start out this question by marking in the radius. So here's a radius, there's a radius, and there's a radius. And then you can see that you have now created a isosceles triangle. And then from there, you can find angle number 1 by taking 180 degrees and subtracting 120 from that, which gives you 60, and then divide that by 2, which gives you 30 degrees. So the corner angles will be 30 degrees. So this angle number 1 is going to be 30 degrees. All right, so for angle number 2, let's focus our attention on the angles on a line concept. So this angle right here, angles on a line. So this angle right here is going to be 180 degrees minus 120, which is going to be 60 degrees. So that's going to be 60 degrees right here. And notice that once again, we have another isosceles triangle. So if I want to find angle number 2, I would do 180 degrees minus the 60 degrees, which is going to give you 120, and then divide that by 2, and that gives you 60 degrees as well. So the corner angles here are 60 degrees and 60 degrees. So angle 2 is going to be 60 degrees, and if I add angles 1 and 2 together, I do get 90 degrees for that particular problem. Okay, let's move on to the next one, letter B. Now for letter B, there's an inscribed angle right here at the top, and for this inscribed angle, if I follow the sides, it does open to the diameter. And anytime an inscribed angle opens to a diameter, that means the inscribed angle has a value of 90 degrees. So that angle is 90 degrees. Okay, from there I need to find the value of x now. So I know that this angle, x, and the 2x, and that 90, those three angles, they do add up to 180 degrees. So let's go ahead and write that out. So 2x plus x plus 90 degrees equals to 180 degrees. So that's the setup that I can have for that particular problem. And then let's go ahead and just add this up. So 2x plus x, that's going to be 3x plus 90 equals to 180. And then if I bring the 90 over, 180 minus 90 is going to be 90 degrees. And then I have a 3x there, and then I can divide both sides by 3. That means x equals to 30. Okay, so let's go back to the original problem now. This is going to be 30 degrees. And then if I double x, 30 times 2, that's going to be 60 degrees. And then that will give you the full 180 degrees there. So angle A is going to be 60 degrees. Okay, let's move on to the next one, letter C. Okay, for letter C, at the top here, this inscribed angle, that's going to be 90 degrees. And the reason is because if you follow the sides, it does open to the diameter. So anytime an inscribed angle opens to the diameter, which is one of the main concepts for lesson number 3, then that inscribed angle equals to 90 degrees. Okay, and then based on these markings right here, this marking and that marking, you have an isosceles triangle. So that means this angle should be 45, and this angle should also be 45, because the two corner angles should be equal in an isosceles triangle. And those three angles will add up to 180 degrees. So angle 1 is going to be 45 degrees. Okay, let's move on to letter D here. Okay, for letter D, I noticed that the radius is marked right there. So here's another radius, and the question tells you that all three of these sides are equal. So this particular triangle here that I'm shading here in blue, that's an equilateral triangle because all sides are equal. And if all sides are equal, that means their angles are equal. So that's going to be 60 degrees, 60 degrees, and that's going to be 60 degrees. And then from there, you can do the angles on a line concept. So that red angle adds up to 180 degrees. So 180 minus 60 is going to be 120 degrees. So let's go ahead and put that in. This is going to be 120 degrees. And we have another radius over here. Sorry, this is 120 degrees. Got to write that in correctly. And then this blue triangle right here, you do have an isosceles triangle there, so the corner angles are going to be equal. So if I do 180 minus 20, 120 degrees, there's 60 degrees left. So 60 degrees divided by 2, that's going to be 30 degrees. So each of these corner angles should be equal to 30 degrees. And that ensures you that that blue triangle does add up to 180 degrees. Okay, so that's going to be 30 degrees as a final answer. Okay, let's move on to another one here. Okay, so this angle right here in the top corner here, it's blue one, this is an inscribed angle. And once again, it does open to the diameter. And any inscribed angle that opens to a diameter has a value of 90 degrees. So if I take this expression right here, this 2x minus 12, that's going to equal to 90 degrees. And then if I take this negative 12 and if I bring it over, then I have 2x equals to 90 plus 12. So 2x would equal to 102, and then I can divide both sides by 2, and then x would equal to 51. Okay, so x equals to 51, and what we need to do now is we actually need to go ahead and find the actual angle values. So let's go back to the original problem here. So this angle here, this green angle, that's actually equal to 90 degrees. And then let's go ahead and find this angle right here. So I know x is 51, so 51 minus 31, if we do the calculations on that one, that should be 20 degrees. Okay, so I have 90 degrees and 20 degrees, and that means angle 1 has to be 70 degrees, because 70 plus 20 plus 90 is 180 degrees. So angle number 1 is going to be 70 degrees, but you do need to find the value of x first before you are able to find angle 1. Okay, let's keep on moving along here. Letter F. Okay, so for letter F, up in the corner here, I do have another inscribed angle. And if I follow the sides, it does open to the diameter once again. So this is the main concept for lesson number 3. Any inscribed angle that opens to the diameter has a value of 90 degrees. Okay, so we know that corner angle there is 90 degrees. Now take a look at this triangle here. I'm just going to highlight that in blue. If I take a look at that big triangle right there, you know, you have your 34 degrees. And you have 9 degrees right there. What that means is you should be able to find this entire angle here, because that's a big triangle, and a big triangle, regardless of what kind of triangle you have, it adds up to 180 degrees. So if we do the math here, 180 minus 9 degrees minus 34, that's going to give you a value of 56 degrees. Okay, so this green angle right here is going to be 56 degrees. And what we can do now is I can take 56 degrees and divide it by 2. And the reason why I can do that is because of this now. If I follow up the sides on angle 1, it opens to this arc over here. And if I take a look at this angle here in blue, if I follow the sides to that angle, it opens up to this arc over here. And these little markers, they tell you that these two arcs are equal. So if you have inscribed angles that open to the same arc, then they have the same angle value. So both those angles have to be equal. So that means I got to take this 56 degrees and divide that by 2, and that's going to be 28 degrees. So that's going to be 28, and that's going to be 28. So angle number 1, after a little bit of work, is going to be 28 degrees. Okay, and to find angle number 2 is actually a little bit easier to find because you can focus your attention on this blue triangle right here. And you know that this corner angle is going to be 90 degrees, and you know angles in a triangle add to 180. So 180 minus the 90 minus the 28, that's going to give you a value of 62 degrees. And 62 degrees is angle number 2 there. Okay, so that's how you solve that particular problem. Let's move on to the next 2 questions for the first page. Do letter G now. Now for letter G, some of the techniques that you have to use are very similar to the previous problem. And I know that these two angles here at the bottom, those two blue angles, they're going to be equal to each other. And that's because if you follow their sides, they do open up to these arcs above here. And if I follow these green sides, that bottom angle opens up to the green arc. And the green arc and the blue arc, they're the same because of these markings. So those two bottom angles have to be equal. All right, so let's just keep that in mind as we're doing this problem. Now this particular angle right here in red, this is an inscribed angle, and that equals to 90 degrees. And the reason is because if you follow the sides, it does open up to this diameter. And if an inscribed angle opens to the diameter, then that inscribed angle has a value of 90 degrees. So that's one of the main concepts for lesson number 3. And then from there, take a look at this triangle right here. We know that triangles add up to 180 degrees. So if I have 180 degrees, I can take away the 90 and the 42. And if I do 90 minus 42, I get 48 degrees. So I know that this entire angle here, that's going to be 48 degrees, but then I can split that in half because both those angles are equal to each other. And then I get a value of 24 degrees for those two individual angles. So angle 1 is 24 degrees, and this angle there is also 24 degrees. Okay, let's move on to letter H. Okay, for letter H, I will go ahead and mark in this radius, and then I will also mark in, I'll put two sides here. Just one sec, that didn't work out. So let me mark in that, and I'll mark in that. So there's my radii, and here's another radius there just for good measure. Okay, let's take a look at this angle right here, this inscribed angle. Okay, so if I follow the sides, 20 degrees opens up to this particular arc right here. And if I take a look at this green angle, just one sec, get a green marker here. So this angle right there, this right here is a central angle, and if I follow the sides of that central angle, it opens up to this arc right here. And I do know that these two arcs are equal because of the markings there. So the central angle and the inscribed angle, they open up to the same arc. So that means the central angle is going to be double the value of the inscribed angle. So this angle right here is going to be 28 times 2, which is going to be 56 degrees. Okay, so let me just erase all this, and let me just relabel the diagram here. So this angle is going to be 56 degrees. And I do know that I do have an isosceles triangle there. And now I can find angle number 1 because I can do 180 degrees minus 56. And if I do that, I get 124, and then I can divide that by 2, and that gives me 62 degrees. So this is going to be 62, and that's going to be 62. So those two angles are equal. And I think that's it for that particular question. Yeah, so that's it. So angle number 1 is going to be 62 degrees. Okay, let's move on to the next page. All right, question number 2. Okay, now we're dealing with quadrilaterals, 4-sided shapes inside a circle, inscribed inside of a circle. So if this is 100 degrees, I know the opposite angle has to be 80 degrees. So because opposite sides have to add up to 180. So angle number 2 is a little bit easier to find, that's just 80 degrees. And then because of these markings right here, it just means the sides are equal. So if this is 80 and that top's 100, then this side is going to be exactly the same side, exactly the same as the opposite side. So that means this angle is 100 and this angle is 80. Okay, so angle number 1 is also going to be 80 degrees because both sides are going to be equal. Okay, let's move on to letter B. Okay, so for letter B, I know this corner angle has a value of 110, and since we have a 4-sided shape, I know the opposite side of any 4-sided shape that's inscribed inside of a circle adds up to 180. So 180 minus 110 is going to be 70 degrees. So that's going to be 70 degrees right there. Okay, and then you'll notice that we do have an isosceles triangle right there. So that means this has to be 70 degrees. And then that means angle 1 mathematically should be 40 degrees. So this right here is going to be 40 degrees. Okay, let's move on to letter C. Okay, so for letter C, I will look at the angles on the line right here. So that's 100, then this has to be 80. Because angles on a line add up to 180 degrees. And then these two opposite angles add up to 180, so this has to be 100. So angle number 1 is going to be 100. Okay, and then let's move on to the next one. Letter D. Okay, so for letter D, you should recognize up here we do have an isosceles triangle. So that corner angle is going to be 40, and this upper angle is going to be 100. That gives you 180. And then these two opposite angles inside, so four-sided shapes inside a circle, they add up to 180 on the opposite ends. So this has to be 80 degrees. And angle 1 is going to be 80 degrees. Okay, let's move on. Letter E. Now for letter E, just be careful here just because the question is asking you what do angles 1 and 2 add up to. So these two angles, they just add up to 180 degrees, right? So they just add up to 180 degrees and that's it. Okay, moving on to letter F. Okay, so if this is 70 degrees, then the opposite angle here has to add up to 180. So this should be 110. Okay, once you have 110, notice that this triangle here is an isosceles triangle. So, 180 minus 110 gives you 70 degrees left, and then you got to take 70 degrees and divide it by 2, which gives you 35 degrees. So these angles right here are 35 and 35. So angle number 1 is 35 degrees. Okay, let's move on to letter G here. For letter G, I know this is 90. And this here's 25, so right away we can find this angle right here because we're working with this blue triangle. So let's work with that blue triangle first because we know triangles add up to 180. So that's going to be 180 minus 90 minus 25. So 180 minus 90 minus 25, that's going to be 65 degrees. So this angle here is 65. Then let's erase the colors here. And then we know that the opposite angles in a quadrilateral add up to 180. So if I want to find that, that's going to be 180 minus 65. So 180 minus 65, that gives you 115 degrees. Okay, so let me just label this as 115 degrees. And then finally, we have one more isosceles triangle up in the corner here. So if I want to find the corner angles, it'd be 180 minus 115. So 180 minus 115 is going to be 65, and 65 divided by 2 gives us 32.5. So angle number 1 is 32.5. All right, so that's that particular angle, and that should do it for that one. Okay, and then let's move on to letter H. Now for letter H, a very common mistake that I think students do make is they see this 110 and they automatically assume that angle A has to be 70 degrees because the concept is in a four-sided shape, the opposite angles add up to 180. But that only applies when the four-sided shape is touching the edges of the circle. And unfortunately, this point right here, that red dot, is not touching the edge of the circle. These angles right here, they're definitely touching the edge of the circle, but the red one's not, so we can't really apply the quadrilateral rule for this particular problem at the moment. So what you have to do for this problem is you need to extend the diagram here. So I'm going to take this point and extend it there, like that and that. And what I've done here is I've created this inscribed angle. And this 110 is my central angle, right? And the ascribed angle and the central angle, they both open up to this arc right here. So that means the inscribed angle is going to be half of the central angle. So 110 divided by 2 is going to be 55 degrees. Okay, so that's a rule from lesson number 2. Now take a look at this purple region right here. This purple region, that's a four-sided shape where all the edges are touching, the circle. So now we can apply the rule now. So I know that this 55 degrees and angle A, the opposite angle, those two angles add to 180 because all the sides are touching the edges of the circle. So in order to find angle A, it would be 180 minus 55. So 180 minus 55 is going to be 125. And that's how you would solve that particular problem. Angle A is 125 degrees. Okay, a few more questions to go here, and we should be almost done this homework guide. Okay, so for question number 3, let's go ahead and mark in the radius. So here's a radius, and there's a radius, and there's a radius. And then right over here, we do have an isosceles triangle there. Okay, so for an isosceles triangle, we know that it adds up to 180. Let's take away the 50 degrees, and we get 130. And then 130 divided by 2 is going to be 65 degrees. So these corner angles are going to be 65 degrees. Okay, and the reason why that's going to be useful now is because take a look at this four-sided shape. All the edges are touching the circle, and this 65 degrees that we just found and this angle C, they both add up to 180. So 180 minus 65, let me do that really quickly on the calculator here. That gives me 115 degrees. So that's going to be 115 right here in the corner here. So 115 degrees right there. So angle C is 115 degrees. Okay, let's move on to question number 4 here. Question number 4, a little bit of algebra here. Okay, so but let's start with this corner angle here, this x and this x plus 80. So I know these two angles here, they do add up to 180 degrees. That's x plus 80 equals to 180. And x plus x is 2x plus 80 equals to 180. And then if I take this 80 and bring it across, I have 2x equals to 100. And then I can divide both sides by 2, and x would equal to 50. Okay, so x equals to 50, I found that. And then let's go ahead and find y by using the same technique. So y plus 100 and that y, these two angles have to add up to 180. So y plus 100, that equals to 180. Okay, and y plus y is 2y equals to, if I bring this 100 degrees over, 180 minus 100 is going to be 80 degrees. And then divide both sides by 2. Y would equal to 40. Okay, so that's how you can find the values of x and y. Okay, let's move on to the next one. I think number 6 is the next one that's been assigned in the homework. And for question number 6, I need to find the radius here. So the radius is this distance right there. And I guess we have some information over here to kind of work with. Okay, so one thing that I would recommend is I would just create a triangle by drawing another radius right here. And you should also recognize that if I take this blue marker here, this is also a radius, right? So that whole thing is a radius as well. But what you should also now focus on is, what is this yellow distance? What's that going to be? Well, I know this entire distance here is the radius, and I know that this distance here is just 2. So that means that this distance right here is going to be r minus 2. Okay, so that will give you the yellow distance right there. That yellow distance there is r minus 2. And hopefully that makes sense, because you take this whole length and you just subtract that purple length, and then you should get the yellow length, which is r minus 2. Okay, so let me just kind of redraw that triangle right here. This is 6, this is r, and this is r minus 2. And what we're doing now is we're just applying the Pythagorean Theorem here, and now we're just solving for the radius. So if I apply the Pythagorean Theorem here are my legs. So I have 6 squared plus, and then r minus 2 is all going to be squared, equals to the hypotenuse, which is just r squared. So now you have to deal with this expression here, which takes a little bit of work. So this is going to be 36 plus. Now this 2 means you need to double up the brackets by writing it out twice. And then you need to apply FOIL here. So r times r is r squared. R times negative 2 is negative 2r. And then the insides would be negative 2r. And that would be negative 2 times negative 2 is plus 4. and that's going to be 36 plus that equals to r squared. And then let's go ahead and do a little bit of math here. This r squared and that r squared will cancel out. If I do 36 plus 4, 36 plus 4 is 40, and then those can cancel out. And then we're going to do this calculation here. I lost 2 rainbows and I lose 2 more, so I've lost 4 rainbows in total. And that equals to a 0 on the right hand side there. And then you can take this 4r and bring it over. So if it's negative, it now becomes positive, which is 4r equals to 40. And then finally, you can divide both sides by 4. And you should get 10 for the radius. All right, so a little bit of algebra for that particular problem there. So please do ask questions in class if you're not familiar with how to do the algebra on that question. Okay, 2 more questions to go, and then we should be done this homework video guide. Question number 7 here. So for question number 7, I know we're going to do the Pythagorean Theorem again. I know this angle right here is going to be 90 degrees because anytime you have an inscribed angle that opens to the diameter, we know that has a value of 90 degrees. That's the one thing we need right away. And we know that this length here is 8.5 because that's the radius, and I know that this length is also 8.5. So 8.5 plus 8.5 is going to be 17. So if I kind of redraw the triangle right here again, the diameter is going to be 17. This is going to be 90 degrees, and I know this value is 8. And I need to find the value of AB, which is this blue length right here. So let me just label this side as just x to find AB. And for this particular problem, we just use the Pythagorean Theorem one more time. So 8 squared is the leg here, plus this leg, which is x squared, equals the hypotenuse, which is 17 squared. And then we got to just crunch out the numbers here. So 8 squared is 64, plus x squared equals to, well, 17 squared is 289. And then I take my 64 and bring it to the other side. So that's going to be x squared equals to 289 minus 64, which is 225. And then you can take the square root of both sides. And x would equal to, the square root of 225 is 15, I believe, yeah. So for that particular problem, the answer is 15. Okay, let's just do one more question here, and I think we can finish off here. Question number 9. So for question number 9, the trick is you want to create another line right here. And once you do that, you have your 4-sided quadrilateral, and you know that these 2 angles add up to 180, so we know that this corner angle here has to be 110 degrees. And that's 110 degrees. Check out this angles on a line right here. So that means this inside angle has to be 70, and then this opposite angle here has to add up to 180, so this should be 110 as well. So right here, there is a 4-sided quadrilateral right there, and the opposite angles add up to 180. So angle B is going to be 110 degrees. Okay, so that one's not too hard to figure out. Once again, if I had to recap that problem, the main thing is you got to draw a vertical line right there. These 2 angles add up to 180, so that's 110. And then this angle and this angle add up to 180, so that's going to be 70 degrees, and then these 2 angles add up to 180, so that has to be 110. So that's the that's how I can summarize that last problem there.